And now I'd like to welcome Chris Van Buten, Vice President, Technology and Innovation Research and Engineering for Sikorsky Aircraft, to talk about redefining impossible in vertical lift.
Good morning. Appreciate this opportunity to give you a glimpse of what we're working on to define the future of vertical lift at Sikorsky Lockheed Martin Company. And first, it's exciting for us to be sharing a one-year anniversary as a Lockheed Martin company, and we're starting to really get the traction around combining the technology and talent from the Lockheed Martin Corporation with the best we have at Sikorsky. And you're going to start to see that in our next generation of products. Here we go. These are my two favorite helicopter pictures. When you talk about the future of rotorcraft, it's important to celebrate what they already do incredibly well. Remarkable mobility, infrastructure independent mobility. The ability to sit on that craggy outcropping in Afghanistan and deploy or recover troops is absolutely outstanding. The ability of a Black Hawk to hover over a family in distress during Hurricane Katrina and let the family get organized, get the kids' backpack ready, have mom hold baby in arms, and get everyone on board is what we do, and an incredible value we provide to society. The challenge as we look to all these new configurations right? So that's a fun element of the challenge of this next generation of vertical flight. The current products are absolutely amazing, but we've heard the customers say, I want to fly at 6K 95 ambient conditions. I want to operate on a 300-kilometer box battlefield, and I need higher speeds to do that. And I want to fly farther. We'd also say I need to be more survivable in a future peer-on-peer battlefield. I need to be more agile when I get to the fight. So it's amazing. You talk about the application of impossible to rotorcraft. I am a student of the University of Maryland, down the street, 25 miles from here, and I took the Al Gessow class. He's a pioneer in rotorcraft, in helicopter aerodynamics, and at the time, he taught us about the peak figure of merit, the measure of rotor efficiency that the industry would probably ever achieve. The 53K that's flying now, West Palm Beach in our Development Flight Test Center, Marine Corps heavy lift helicopter, 88,000-pound gross weight, 21,000 horsepower, flies with a figure of merit that I was taught was impossible. It flies with a level of rotor efficiency. It converts onboard power to lift and payload for the warfighter at a level of efficiency that I was taught would never happen. It's a remarkable advancement in the industry. The computational fluid dynamics and optimization that's now possible in these systems is tremendous and is enabling new things. That capability is tripling the Marine Corps hot day lift capability for the Marines while retaining the shipboard compatibility of the 53E. 150% increase in hover altitude, 300% increase in payload, all enabled by this new generation of technology. As we look to FVL, we've been very transparent about our strategy. Demonstrate in a new configuration X2 technology with the X2 technology demonstrator. We succeeded at flying 250 knots in 2010, and we just recently inducted that into the Udvar-Hazy Smithsonian Air and Space Museum. And then we're going to fly two vehicles. We're flying the S-97 Raider. We're bracketing the future vertical lift capability requirements with a small, urban, capable ITEP engine relevant FVL vehicle with Raider, and then a larger CapeSat 3 compliant vehicle with our partner Boeing called the Defiant. Raider is in flight test in West Palm Beach, and as Marilyn mentioned, it's going to fly well over 220 knots. And it flies at half the acoustic signature and has double the maneuverability. The combination of these attributes provides tremendous capability for the future warfighter. Look at the map of Afghanistan, where a typical helicopter has restrained operational capability due to its high performance. A Raider-type vehicle with ITEP engines can operate across Afghanistan, operating at beyond 6,000 feet, 95-degree conditions, and can serve, again, at double the speed of the typical helicopter and operate at greater radii, reduced signatures, and significant improvements in turn radius, enabling it to survive on the modern battlefield, the battlefields we expect of 2030 and beyond. We're very excited to be working with Boeing. And imagine the combined strengths of Boeing and Lockheed Martin working future vertical lift. We're building, the Defiant has the utility fuselage here. We're envisioning the drivetrain being readily adapted to both attack variants and assault capable variants. You'll see more and more of the attack version of an FVL option as we move the technology forward. And imagine that vehicle, it not only has to traverse the battle space, an enlarged battle space at higher speed, it has to survive when it gets there. High threat assault and attack environments, peer-on-peer threats. So look for more and more in terms of what it takes to survive at that objective, a critical element of what that future solution needs to look like. Then here's those measures, compared to a Black Hawk doing troop assault. Significant, growth in the hover altitudes designed for 6K95, designed for that enlarged battle space, half the noise again, and improved maneuverability. And that operational capability significantly expanded in operating environments like Afghanistan. Let me shift for a second. Coming up is the discussion with the mad geniuses of vertical flight. There's all new configurations that are now enabled by a few fairly disruptive trends. One is the coming of autonomy technology and the very high degree of computation that we can embed in these future platforms. At Sikorsky, and this was Redefining Flying, was another publication's translation of what we're doing as part of the DARPA Alias program. We've put supercomputers combined with fly-by-wire flight controls, triplex fly-by-wire, in a S-76 helicopter. We've also done it in a Black Hawk helicopter and shown the ability to move from traditionally piloted vehicles to, we've always called it optionally piloted, and we had the 2-1-0 switch to represent that functionality. And now General Gaylor has proposed the word pattern, he and his team. I don't know if they trademarked it yet, but I think it's a great word pattern for the community. Optimally piloted vehicle. A vehicle that's so flexible that when you have 12 troops in the back and you're doing a nighttime assault, there's 2 experienced airmen up front working with a sophisticated vehicle, surviving in the high threat environment, controlling off-board UAVs, working the high workload tasks. But when you don't need that, you're on a milk run, you're moving a couple guys in VFR flight, it's a single pilot flight. Or I'd suggest that the optimal crewing when you're dropping water on the Fukushima nuke reactor is probably 0. And you put the switch to 0 and your Black Hawks move, execute the dangerous or the very dull missions required. This will offer the future warfighters tremendous flexibility and capability, and will be embedded in the current platforms, Black Hawks, and the future platforms, future vertical lift. We're moving from a pilot that is moving sophisticated controls inside the control loop to an operator that sits above the control loop. And we're demonstrating this in flight, again, in commercial and military products, where you put in top-level mission commands instead of specific stick and rudder pedal control inputs. This frees the operator to think about the context of the mission, the tactics of the mission, and execute it at a level of safety and precision that was previously not possible. Imagine that in a Black Hawk, the flexibility of doing troop assault missions at night and during the day, optimally piloting the machine by going to 1 or 0 crew and having that Black Hawk continue to fly missions, moving cargo on the battlefield. And in the spirit of the forces moving faster, farther, hotter, the competition here isn't really against an aviation asset, it's against a 5-ton truck. And we're actually working the economics of enabling the Black Hawks with this kind of functionality, future vertical lift with this functionality, to move cargo in a very cost-effective way on the battlefield, enabling 12x improvement in speed versus the typical convoy operating at about 10 miles an hour, and able to actually move that cargo at a very attractive price per ton mile, because you're fully exploiting the capability of the assets you already have. It's exciting to think about designing this into the future vertical lift platforms. So thank you for this ability to just give you a glimpse of what we're thinking of in terms of expanding the ability for flight in 2030. We're doing things they thought were impossible. Figure of merit, they thought the X2 configuration was impossible. We continue to have a debate on, is flight of a helicopter without an air crew really possible in fully complex environments? We're taking on these challenges, taking on impossible, and creating new options for the warfighter in 2030. Thank you.